Good afternoon, everybody. My name is Kavyan Kunjan Tripathi, and I studied in class 10th A in Kendra Vidyalaya number 1 OF Barmal Balangi. So, now we will see the ray diagram of the concave lenses. So, here I made a table so we can easily locate each of the point for image formation by the concave lens. So, here is the first example. So here we can see a concave lens, the main focal center and two rays. So in the first example, when an object is placed at the infinity, so here the object location will be at infinity and the image location will be at f2. So here we can write image location at f2. A virtual image is formed at the focus. So here in the focus, a virtual and erect image will be formed. So image nature we can write as virtual and erect, and the size of the image is much smaller than that of the object. So the image size will be highly diminished. So we could write image size as highly diminished. So here the f2 where the image location will be there, the object is placed at the infinity, and here in the focus the object will be formed. So here we can see the second example. Here is the concave lens, the focal center, two rays and open beam. So in the second example we could see that when an object is placed at a finite distance, means beyond infinity and the zero. So beyond the infinity and the zero, so from the lens a virtual image is formed between the pole and the focus of the convex lens. So a virtual image will be formed between f1 and the optical center. So here a virtual image will be formed. So here we could write as the image location is between f1 and optical center, and the object location will be beyond infinity and 0. So similarly the nature of the image will be virtual and erect, and the size of image is larger than that of the object. So we could write that image size will be diminished. So that's all for the concave lens ray diagram. Here is the two examples, one at the infinity and one beyond infinity and 0. So that's
Good evening everyone. My name is Bal Aditya, studying in class 10th B of Kendra Vidyalaya number 1 Balangir. Today I am going to explain the ray diagrams of the images formed by the concave mirror. Here we have total 6 situations. First, when the object is at infinity. Here 3 rays comes from the object, and first one reflects like this, and second one reflects like this, and the middle one, which passes through the center of curvature, comes the same way along, and the top and bottom reflected rays are intersecting at the focus. So the position of the image is at the focus f, and the size of the image is highly diminished and point sized, means the size of the image is equivalent to a point, and the nature of the image is real and inverted. Second one, when the object is beyond c, beyond the center of curvature. Here the object is there and two rays comes like this. First, the bottom ray passes through the center of curvature and comes the same way along, and the top one comes like this and reflects from the focus, and the image formed by the intersection of the two reflected rays is below the mirror. Here the image formed is below the mirror and the image is diminished and it is real and inverted. Third situation, when the object is at the center of curvature. Here the one ray is going parallel to the principal axis and is reflected back through the focus, and the second ray is passing through the focus and reflected back to the below of the mirror, and the image is formed below the mirror of the same size and it is real and inverted. Fourth situation, when the object is between C and F. When the object is between C and F, one ray goes parallel to the principal axis and the reflected ray of that ray passes through the focus, and one ray goes from the object like this and reflected through the center of curvature. Both lines intersect below the principal axis and beyond the center of curvature. So the position of the image is beyond C and the size of the image is enlarged than the object and the image is real and inverted. The fifth situation is that when the object is situated at the F, the focus. When the object is situated at F, one ray of the object goes parallel through the principal axis and the reflected ray goes back through the focus, and one ray goes from the top of the object and reflect from the mirror through the center of curvature, and both the lines form the image at the infinity, and the image formed is highly enlarged, and because it is formed below the principal axis it is inverted and the nature of the image is real. The last situation comes that when the object is between the pole and the focus, P and F. When the object is between pole and the focus, the image formed is behind the mirror and it is virtual and erect and enlarged image. That's all.
Good morning everyone. My name is Shreyas. I studied in class 10A in Kendra Vidyalaya number 1 Balangir. In today's activity, we will see the sign convention for spherical lens. Let's look into the both of the lens, which is convex lens and concave lens. So these days, new Cartesian convention is used for measuring the various distances in the ray diagrams for spherical lenses, which are convex lens and concave lens. According to the new Cartesian sign convention, all the distances are measured from the optical center to the lens. The distances measured in the same direction as that of incident light are taken as positive. The distances measured against the direction of incident light are taken as negative. The distances measured upward and perpendicular to the principal axis are taken as positive. The distances measured downward and perpendicular to the principal axis are taken as negative. So, the new Cartesian sign convention for lenses is shown in the figure, in which the object is always placed on the left side of the lens. Okay, so the direction of incident light is from the left to right. All the distances measured from the optical center of the lens to the right side will be considered as positive, because they will be in the same direction as the incident light. On the other hand, all the distances measured from the optical center of the lens to the left side are considered as negative. Why? Because they are measured against the direction of incident light. On the basis of new Cartesian sign convention, the focal length of a convex lens is considered positive. On the other hand, the focal length of a concave lens, the concave lens, is considered negative. So, please note that the sign convention for spherical lenses is very similar to the sign convention for spherical mirrors, which we have already studied. So that's all for today's physics activity. Thank you and have a nice day.
Good morning, one and all present here. Today I, Anubhav Panda from class 10th A, is here to explain sign convention for spherical mirror and ray diagrams of convex lens. So let us start with the sign convention for spherical mirror. The following sign convention is used for measuring various distances in the ray diagrams of spherical mirrors. So the first one is object is always placed to the left of the mirror. The second one is all distances are measured from pole of the mirror. The third one is distances measured in the direction of the incident ray are positive and the distances measured in the direction of direction opposite to that of incident rays are negative. The fourth one is distances measured above the principal axis are positive and that measured below are negative. So here is a diagram which explains the sign convention for spherical mirror.